So now we're going to take a look at two different functions that are actually very important to computer science and that will represent some pretty good examples of functions and will allow us to kind of expand our understanding of that concept. All right, so the first one we're going to look at is something called the floor function. And the floor function is a function that maps f from r, the real numbers, onto the integer z. Okay, and how we write it is we write it as f of x equals x. Okay, and what it does is that the floor function, it'll go in and it'll take whatever value you have for x, and it will ascribe to it the smallest integer value that is less than x. So for example, if we take f of 2.5, that's going to equal 2 because 2 is actually the largest integer that is less than or equal to 2.5. F of 3.4 will then thus equal 3. F of, and when we think about negative numbers, you've got to be careful with this. F of, say, negative 1.5 is going to equal negative 2 because that's actually the integer that's less than negative 1.5, not negative 1. Remember, we're going in the opposite direction when we actually work with negative numbers. In addition to that, f of 1, for example, is just going to equal 1. All right, so when we think about our mapping, that's how that mapping is going to go. So what we'll have, say, for example, we'll imagine a mapping like 3 will map to 3. 3.5 will also map to 3. 3.001 is also going to map to 3. So we actually have a lot of stuff that's actually going to be mapping to 3. Negative 1 will map to negative 1. Negative 0.5 will map to negative 1. If you kind of think about it, that's what's going to happen. Negative 0.002 is also going to map to negative 1. So we imagine that's what's going to happen with this particular function. So if we kind of think about what is its domain, what is its range, well, the domain's pretty simple. The domain on the floor function is going to be all real numbers because we can always find an integer that is less than a particular real number. Okay, that's pretty simple. The range then is going to be a little bit trickier, and we kind of have to think about this logically. So 1 is we're only going to end up with integers. So whatever we look at, it's going to be a subset of the integers. So I believe that if we think about it, like, can we get every integer? Well, yes. I mean, the fact is that you can get any integer that you want. All right. So the range will end up being the set of all integers. So when we think about our mapping, here's our mapping. It's going to go from R, okay, it'll go into Z, the set of all integers, right? And we'll imagine that function, that floor function, right, doing this. So like say, for example, negative, like we said, 1.5 will go on to negative 2. Negative 1 will go on to negative 1. Negative 2 will go into negative 2. 0 will go to 0. So on and so on and so forth. And that actually represents what this mapping looks like. Now, there is a converse of the floor function, and it's called the ceiling function. And so here's how the ceiling function works. Okay, the ceiling function is a function f from the real line onto the integers. And it's going to be, we're going to say f of x equals, and it'll be x. And what it is it's going to, it's not going to look like that. It's going to look like this. Right? Whereas the other one had a floor, this one's going to have a ceiling. All right. And what it's going to do is it's going to give the integer that is greater than whatever the real number value is. So for example, okay, we'll take 1.5, and now the one that's above 1.5 is going to be 2. Right? 1.75, that's also going to be 2. Okay? 2 will also be 2. Okay, negative 1.6. Well, now negative 1 is in fact the integer that is just greater than negative 1.6. Negative 0.7, thus, will go on to 0. And we have something like negative 0.25. Okay, that'll also go to 0 because that's the integer that is just greater than 0.25. And then again, we'll imagine our mapping. Here's R, our domain, Z, our codomain. And the question we might ask ourselves is what is the domain? Well, the domain's going to be all real numbers. We could always just find an integer that is just greater than any real number. And our range is going to be the set of all integers because, again, there's really no restriction, right? We're going to have negative integers in there. We're going to have 0. We're going to have the positive integers. And we can't really imagine any that would be less than, or that would be actually eliminated or not in there. So here's our ceiling function. Okay. And like we said before, we'll take like negative 1.6 is going to go to negative 1. Okay. Negative 0.7 will go to 0. Negative 1.3 will go to negative 1 again. 2.7 goes to 3. So on and so on and so forth. And that's the ceiling function. So those are two functions where what we have is our domain and codomain are not in fact the same thing. In both the ceiling function case and the floor case, we have that we're going from the real number line onto the integers. Okay? And we just have to be careful about how each one is defined. All right, great. That concludes the video.